Hi everyone, thank you for coming. My name is Runa Sandvik. I work for the Tor project as a developer. I also do support translations, packet analysis, and a whole lot of other things. So today I'm going to talk about how Tor is being blocked and censored, both toward the software and toward the website and our users. How many of you were at or saw the Tor talk at CCC last year? Okay, good. So Roger Dingledine and Jacob Applebaum gave a talk at 28C3 last year about how governments have tried to block Tor. And what they covered were the events that we've seen up until that point. What I'm going to try and cover in this talk is just a quick summary of their talk, but also what we've seen so far in 2012. So who knows what Tor is? Okay. So Tor is a free open source program that allows you to be anonymous online. So it allows you to visit websites without anyone seeing which sites you're visiting, what you're doing, who you're talking to, and so on. It also means that your ISP, for example, cannot see which sites you visit. So Tor was originally developed by the US Naval Research Labs. So it is a US government project. It was developed for the purpose of protecting government communications. That was like the initial purpose. They wanted to be able to communicate anonymously and encrypted, and so they developed this tool. It was only later that we kind of realized that it could be used for circumvention as well. So the source code was released in 2002, so we're coming up to like the 10-year anniversary of Tor. And the paper was released in 2004, and in 2006, the Tor Project Inc., the US nonprofit, was created. So today we are about 20 paid contractors and employees, and 1/3 are females, which is pretty cool. So this is a very kind of simplified model of how Tor works. You have your client, you have 3 hops, and then you have whatever site you want to visit. So when your Tor client first starts up, it will download a list of all the servers, of all the relays in the network. And then it will pick 3 of them, 3 random ones that it will use for its circuit. Then it will contact the first one, and they will agree on a session key to use. And then it will, through the first one, contact the second one and agree on a different session key, and so on for the 3rd hop. So that when the whole circuit is kind of complete and it's time for you to send your data, the data will be wrapped in first like a layer for the 3rd hop, an encrypted layer for the 2nd hop, and then an encrypted layer for the 1st hop. So when that is passed on and it reaches the 1st hop will peel off like the layer of an onion. That's why we have the onion as a logo. So it will peel off the first layer, see that it's gonna send the data off to the 2nd hop receives the packet, peels out the 2nd layer, reads the message in there, passes it on to the 3rd hop. The 3rd hop is the only one that will see where the packet is going, which site you're trying to visit. So the 1st hop will know that you're using Tor, but that said, it won't know which site you're trying to visit, which site you're trying to log on to, or anything like that. The 2nd hop will only know that, okay, here's a packet, it came from somewhere in Tor, it's going to somewhere in Tor, and that's it, it will just pass it on. 3rd hop will know that someone is trying to log on to Facebook using Tor. That's it. So I don't know how readable that is from the back. Is it okay? Cool. So here's the from Wireshark. It just kind of illustrates the whole connection where the beginning of the TLS handshake, when the client first talks to the 1st hop and they agree on that session key to use, and the server will kind of choose the cipher suit, and they will kind of keep on talking for a bit, and then the connection will be set up. But in a lot of cases, when Tor is being blocked these days, it's with deep packet inspection. So they somehow identify that it is a Tor connection and they block it based on that. So here, from Ethiopia, you see that you have the beginning of the TLS handshake. Then the client will send some information about what kind of ciphers it will choose, or you can choose from. So the server will just kind of pick one of them and then send some info back. And then in this case, the firewall will kind of just recognize one of them and then block based on that. That's kind of like a very common way of doing it. A lot of deep packet inspection devices seem to recognize one of the cipher suits used. So we found that if we choose a different one, then we're able to circumvent the firewall. But there's a lot of different ways of kind of blocking Tor. I'll get back to that later. So 2002, Tor was released. 2004, the paper was published. That's when kind of the arms race began. That's when people started using it a bit more, and we realized that it was also possible to use this for circumvention. So some indicators that we have that Tor is being blocked, or that some new country rolled out a deep packet inspection device, or that something's going on somewhere, is an increase in downloads of the Tor browser bundle. That's kind of like the main bundle that we have, where you get Tor and you get the browser and everything just works. So an increase in downloads usually says something about a blocking event somewhere. Like Twitter got blocked in Pakistan and thousands of people downloaded the software. So we publish the logs. We try to sanitize the logs a bit so they do not contain IP addresses. We actually don't log the IP addresses anyway, so we don't have to sanitize that. If you visit our website, we do not log your IP. We log whether or not you're using the HTTP or the HTTPS version, and then there's like a date and a time. So you can go online, you can see the logs. We also have this anomaly-based censorship detection system, which we have this way of counting anonymous users. So we can graph how many people are using Tor in the UK. And if this system then detects like a massive spike or a massive drop indicating a potential censorship event, then it will also now send out emails. So we have a mailing list that you can kind of keep an eye on. Even if you start getting emails from that one, then something's up somewhere. Unblocking of the Tor project website seems to be common. It happened in the Philippines a couple of months ago. All of a sudden, the Tor project website was available. People could download the software, they just couldn't connect to the network. And then there's also like an increase in emails sent to the help desk. We normally get around 400 support tickets a month. So if there's an increase and we get like 600, 700, then yeah, there's something up. So between 2006 and 2009, so I think 2006, that's when people started using Tor a bit more, started getting a bit more known, and people started trying it out. So Thailand did kind of like the first step. If you want to block Tor, what do? You block the website. Make sure no one can get the software. So that's like a good first step. But then we have a way of getting the Tor browser bundle via email. So we have this bot. If you email it and say Windows, you get the Tor browser bundle for Windows back. So you can still connect. In 2006, Smart Filter and WebSense created this filter and basically cut all GET requests for any URL that had /Tor/ in it. So when I said that when the Tor client first starts up and it has to download the information about the relays, if you can't download that information, then you can't connect because you don't know about any relays. So what we did at that point was do HTTPS instead. So we got around that, and that still works. Iran has been throttling, blocking, unblocking, doing lots of things. They throttled SSL back in 2009, and because Tor tries to look like normal kind of Firefox on the wire, they got Tor for free. And that is actually still the case in Iran, but I'll get back to that as well. In Tunisia, they blocked all but port 80 and 443. And if you're extra special, they will block port 443 just for you as well. So when we moved from having the directory fetches on port 80 to port 443, and they blocked 443, then you couldn't download the information, so you couldn't connect. And so we set up a different server where you can do HTTPS over port 80. And China. So China is, when it comes to like the countries that try to block Tor, where we kind of have like a really kind of, we can really talk about an arms race, then that would be China. How many have heard about bridges? Okay, so remember the image with the 3 hops that you had, you connect and then you send your data through those 3 hops. If all of those are blocked, so the list that the clients have to download to learn about the relays in the network, that's all public. So China downloaded that and they blocked all the IP addresses. That was like the first thing they did. So it means that if you can't actually connect to any of them, then yeah, you'll be pretty sad. So we created bridges which are private, we don't actually announce them publicly, private servers that you need to learn about somehow to use them. So you can tell your Tor client to connect to a bridge, and a bridge will just replace the first hop. So the bridge, you send your data to the bridge, to the second hop, to the third hop, and then out. So we have these bridges, and they're put in bridge buckets, or like in a database, so we have different pools depending on how we're going to give them out to users. So if you go to bridges.torproject.org, then you will get like 2 or 3 IP addresses that you can use. You can also email us and we'll send you 3 different ones that you can use to connect. So in 2009, China managed to enumerate the web one, the bridges.torproject.org. I don't know if they just didn't know about the email one or if they just hadn't tried. So that's what they did back in 2009. Since then, they have been kind of gotten a bit more sophisticated. They do have a lot of manpower. They really do want to block Tor. And so far, they've been doing a pretty good job, actually. So since then, so that was 2009. Then the Arab Spring happened. Up until the Arab Spring, there was just kind of a lot of like a standard blocking, like block the website or block the public IP addresses or things like that. It wasn't as much of like an arms race as it is after the Arab Spring. So with blue coats in Syria, in different countries, we also got an increase in users. A lot of people learn about Tor for being kind of the one way that you could reach Twitter and Facebook and still kind of spread the word about what was going on. People learned that Tor was better than just a normal VPN client. It's actually anonymous and not just kind of promising you that they're not going to sell your data to someone. And the Arab Spring was also, up until that point, sure, we got some good media, but we also kind of got the, Tor is that one tool used by bad people to do bad things. Since the Arab Spring, there's been more kind of positive stuff in the media, like we're actually helping activists do good things. So we have around like somewhere between like 400,000 and 500,000 users now. In Iran, we still have 40,000 users. Syria, last time I checked, still around 15,000. But I do believe that Syria is that one country that is currently now, it's more like a civil war. So I think the activists are just kind of slowly fleeing the country. But I don't really know at that point. Like, it's hard to say exactly what's going on. So October 2011 was when we first discovered China's new way of blocking Tor, and then we wrote a paper on it. One of our developers, Philip Winter, wrote a paper covering how China has tried to block Tor and was published earlier this year. It's a really, really good read. So they block the main servers that you download this list of IP addresses from, they block all the public servers. They block a lot of our bridges as well. But then they started to try and do more kind of active scanning. So Philip Winter discovered that someone in China had connected to, I think, the university in Stockholm with SSH. And it's fine, it was a legitimate user, connection is up and running, the user is logged in and everything is great. And then between a couple of minutes and 10 minutes after, they start seeing a whole lot of connections from seemingly random Chinese IP addresses to the same IP. Just try to connect, send some garbage data, and that's it. So that seemed a bit weird, a bit off. So we started wondering if this would happen if the server wasn't SSH, but it was a Tor relay instead. And sure enough, you see the same thing, only in this case, if the IP addresses that do the follow-up scanning detect that it is a Tor server, it will try to set up a full-on Tor connection, do the full handshake, make sure it's actually Tor. And if it is, it will block it. So these days, if you set up a bridge and you think that you're actually helping someone in China, then you're helping one user for a couple of minutes. Because they will connect, and then within 1 or 10 minutes, you will have Chinese IP addresses probing you, and then it will be blocked. So Philip Winter wrote in his paper about anything from how long it's going to be blocked for. It seems like if you try to change the port or make it not look like Tor or make it look like it's not actually listening on that port anymore, then the firewall will just assume that the server is gone and unblock it. So there are ways you can get around that. In January 2012, we noticed that if you have a prepaid phone or prepaid SIM card with some providers in the UK, T-Mobile, Vodafone, 3, O2, T-Mobile in the US as well, probably more, then you cannot reach the HTTP version of the Tor project website. If you go to http://torproject.org and it's a prepaid SIM card, so you haven't verified that you're over 18, you will hit their WebGuard filter. And what's interesting about this is Tor, okay, not really sure why it's on that list. Maybe it's because it's, I guess some lists will put it under proxy avoidance. But apart from that, there's no real reason to block the HTTP version of our website. If you put in the S, then you get the website and it's fine. What we noticed when we started looking at this list is that a lot of normal websites, like the Wayback Machine, and different blogs, Cosmopolitan, normal kind of standard sites like that, are blocked by default. And what's even more interesting is that if you try to talk to anyone at T-Mobile or Vodafone or any of these companies about this, they're not going to tell you why you ended up on the list. But if you ask nicely, they'll just take you off the list. So the Open Rights Group wrote a report. We also have uni.nu covering some of this. I know the Open Rights Group working on, they had a project to kind of try and map out more providers and more websites, but I'm not sure if they have actually published the results yet. But that's something that they're working on now to try and put some more pressure on these companies so that we can learn exactly why our websites are on this list. So February 2012, Iran is probably the country after China that are kind of very, very actively trying to block Tor. Last time I heard, the Chinese and the Iranians have also started working together on these things and kind of sharing secrets and stuff. So they really do like blocking Tor. In the beginning of January, they used DPACT inspection to block Tor. So we followed, when setting up the Tor handshake, the initial connection, the Diffie-Hellman, there's a prime that we chose. We followed the RFC, we followed the spec, when we should make sure we did this right. And turns out we were the only ones actually doing it right. So we were the only ones with that prime for our Diffie-Hellman handshake, which meant that it was pretty easy to block. So once we figured out that that was what they were blocking us on, then we changed it, we rolled out a new version, and users were back online in 24 hours. So then I tried again. in September 2011, on the expiration time of the SSL certificate, because it was just pretty non-standard at that point. So again, we fixed it, rolled out new packages, and within 24 hours, people were back online. So then they kind of started stepping it up a bit. I mean, so they have deep packet inspection. They do standard like IP blocking and also keyword blocking. So they're really keeping an eye on what people are doing, and they really also wanted to block Tor. And yeah, so they're preparing for like their Hello Internet, the one where they're kind of alone in the world and no one can actually exit and talk to or visit websites outside of Iran. There's a journalist at the Washington Post. He was writing an article on this, and I think it's going to be out this week or next week, about how supposedly they're going to flip the switch and turn on the special internet this month. So I have heard that, and I have also heard reports that their firewall is configured a bit wrong, and they have like interesting routes and things like that. And so there's still a long way until they're going to actually flip the switch, if ever. I think Iran also claimed that this whole idea about their special internet is just Western propaganda. So I think no one really knows what they're up to. But in February 2012, beginning of March, they had an election. And normally before elections, they kind of ramp up the censorship a bit. They kind of start trying out new filters. In this case, they kind of realized that the filters they had were not really good enough. So on February 10th, so just before Valentine's Day, they just decided to block all SSL, which is the massive big drop. I'm going to get back to how we solved this one later, but this solution for this one was not just new packages for the users. It included getting people, the volunteers who run all of the servers, to upgrade as well. So it wasn't just like a straightforward fix, but users were back online within like a week anyways. Kazakhstan. So like normally we see blocking events in like Asia and in the Middle East, and then all of a sudden Kazakhstan decided to block Tor with DPI. They block Tor, they block VPNs, they block a lot of stuff. So we kind of managed to get a hold of a user who knows how to run Wireshark, who could actually help us capture the network traffic so that we could analyze and figure out exactly where it stops, exactly where they block Tor. So we found that they do, like they match, so the information that is sent between the client and the first hop, there's a lot of different things going on. There's a lot of kind of values, to put it that way, that you can actually block Tor on. And it seems like they are now blocking Tor in like a number of different ways. They identified Tor differently, so that even if we managed to get around one of them, I'm sure they would still kind of find a different way. So this was one of the first events this year where deep packet inspection was being used, and it wasn't Iran and it wasn't China. And I think since then we have seen the same thing happen in a lot of different countries. So I'd like to take a look at that data again and kind of see if we can learn anything new based on what we have now. So yeah, we went from like, I don't know, 600 users to 100. So it seems like it kind of still works, but it's a bit tricky and you have to be patient, and it's going to be slow. So for a lot of people, they just found different ways of getting around it. May 2012, Ethiopia started blocking Tor with DPI. This was around the time they also blocked Skype. As far as I know, Skype is not banned by law, but it's just blocked. So if you can find a way to use it, then good for you. You're not doing anything illegal, but yeah. So they kind of started with blocking just by, I guess, the server hello. So they had like one way of identifying the Tor connection and blocked it on that. But then we roll out a new version of Tor, which could set up that initial connection in a bit of a different way and then circumvent their firewall. So in July, they kind of upgraded their system to be a bit more efficient in blocking Tor. So what was really interesting about this event is that, so I guess the graph, we can say somewhere between 200 and 300 users. Not a whole lot, but still enough. I mean, you would think that if 300 people use Tor every single day and suddenly they're not able to connect, you would expect to hear from them. Well, not always. Out of like all of these users, I only had one person email me saying it does not work in Ethiopia. And that's kind of how we learn about blocking events, is that even though we see it on the graph, we kind of still have to talk to someone in the country who can help us out and send the data that we need. So I figured if 300 users, only one of them actually emailed, I mean, maybe this has happened before. Maybe they kind of tested their filter at one point. And sure enough, September 2011, Tor was blocked for a bit. And so was other websites. They rolled out deep packet inspection a year ago, and they tested it and no one said anything. And what's even more interesting here is that if you look at who Ethio Telecom signed deals with in like June, July last year, yeah, it's China. Chinese CTE Telecom signed like $1 million deal with Ethio Telecom. A lot of the Ethio Telecom staff have been trained at CTE-backed universities in China. So it kind of seems likely that the Chinese are now helping people in Ethiopia with deep packet inspection, with blocking Tor, and things like that. But I have no proof, so it's like circumstantial evidence at best, but still pretty interesting. June 2012, the UAE, only one ISP is using deep packet inspection to block Tor. I think they have two, so it's Etisalat and Do. Well, they may have like smaller ones, but only like the biggest one is actually blocking Tor. So we managed to get a hold of some users. We're still kind of trying to analyze the event. Mostly because at the moment, we do have a solution that is able to circumvent firewalls, even if they're doing deep packet inspection. So in some cases, it's more of a question of how much time are we going to spend looking at this data and poking at the firewall and trying to figure out what's going on. What we did in this case, and also in the case of Ethiopia, it also works elsewhere, is that we set up this bridge, like the private first hop, and we added a patch that removes one of the common ciphers from the list so that it will just pick another one that may not be, I think it's like just as standard, but the firewall will not filter on it, and so you can circumvent the firewall that way. So users are still able to get online, it still works. So yeah, I mean, they try and it's an arms race, but we do manage to find a way around it. In some cases, like I mentioned earlier, we have those graphs of how many people are using Tor every single day, and if there's like a massive drop or a massive spike, we get an email saying that something's going on. And so the Philippines is kind of one of these cases. We see the drop, we see users are not able to connect, and we don't hear from a single one that actually has a problem. I managed to get a hold of a couple of users. They can all connect to Tor just fine. But last time I checked, Philippines got like more than 10 different ISPs. Some of them are doing deep packet inspection and blocking Tor. Others are apparently not. But this is the one case where our website is available. They can download the package, and then in some cases, it just doesn't work. And I think, so as of yesterday, we actually do have more data about this event. We're just analyzing it now and trying to figure out what they're doing. I mean, it's DPI for sure, but exactly what they're doing is a bit of a different question. What we want to do now that we have more data is just to analyze it all and see, like, is there anything that we can learn from the case of Ethiopia? Is there anything that we know that they're doing in Ethiopia that we can also see that they're doing in Kazakhstan? Any chance that they're using the same provider or the same gear? The second we know that, for example, they're using I don't know, WebSense, for example, and we know how WebSense filters, the next time we see something similar in a different country, we'll be able to kind of start learning what type of devices people use. So that's kind of the point that we want to get to. And I'm pretty sure we will eventually. It just takes some time. And we also do rely on technical users to help us out and actually get the data. So in June, I got an email from a friend in Jordan who said that he tried to visit torproject.org and he was seeing a different certificate. And at first, I thought that this was kind of similar to like the DigiNotar and Komodo incident. Who's heard of those two? So the DigiNotar was a certificate authority who gave out a certificate for torproject.org, Google, and some other sites to a malicious party. And I thought that this was similar. It's like a fake certificate in the Middle East, something's up. So this was what he was seeing. I mean, so it kind of started off okay. I mean, it seemed right, but then the issue name just is like just not what it's supposed to be. And it turned out that CyberRome is not a certificate authority. They don't give out certificates to anyone. They just sell devices that just happen to be able to do man-in-the-middle. That can issue certificates on its own for whatever site you want it to. It's like a unified threat management, I think, device that has like this HTTPS scanning for malware is what they call it. It's like this box that will just intercept every single connection or for the sites that you configure, and will just make sure that there's nothing bad in the traffic. What was interesting in this case was that I work with Ben Laurie, and we found that all of the devices share the same certificate. And this was also published on their website, so which meant that all devices, all CyberRome devices will have the same private key. So if you have a device and you get the private key, then you can intercept traffic from any other CyberRome device. Or you can just import the private key into your perhaps better device and intercept the same amount of traffic, which was a bit interesting. I emailed them. I figured I'd be nice. I'd let them know that they had a problem that they should fix. So I sent them an email, and it started off nicely. Like the reply I got started off nicely. You know, like we know how it goes. Like, oh, it's great to see that you care about security, and thank you for letting us know. Thank you for giving us like 2 days to actually fix this problem. And then at the bottom of the email, they started kind of sounding a bit angry. They felt like I was singling them out, and then they dropped some other vendor names that I should look into. So I thought that was nice of them. They now claim that they have rolled out some like over-the-air fix for this, but I haven't been able to see if it actually fixes the problem. So there's a couple of things that we have done, kind of be like after each blocking event or during each blocking event, we have learned something new, and we've kind of found like a new solution or like a new trick that we can do to protect our users, make Tor work again, and things like that. So one of the things that we did was that we pinned the certificate for our website in Google Chrome. So you know how if you use Google Chrome and you visit a website that's using a self-signed certificate, you will get this like warning, like red background and warning, and Google Chrome will tell you that the site is not necessarily safe. But there's a proceed anyways button, so you can click and you can visit the website. And a lot of non-tech users will not even read the text. They don't really care about the red background. There's a box saying proceed, and sure, they will click it and they will visit the website. In this case, if you're using Google Chrome and you visit our website and you're getting a different certificate, then Google Chrome will not let you visit the website at all. So that was one of the things that we did. It has some issues for users with Windows XP prior to Service Pack 3, but not a whole lot of people run that these days. If you're interested in learning more about certificate pinning and where SSL in Google Chrome is going, then check out Adam Langley's talk from Hope this year. Another thing with it is like we started writing up all the things that we've learned, all the data we have, all the patches that we can add to private servers, all the fake packets that we can send to firewalls around the world to see what they do with them. So we started writing this up, and we have the censorship wiki. So for all of the countries that I've mentioned, we have information about each blocking event. We don't share the packet captures publicly, but if you ask nicely, then sure, I guess you could come and help us out and analyze it. So ops proxy, how many have heard about that? So when Iran blocked all SSL, they also blocked Tor. So at that point, we rolled out the ops proxy Tor browser bundle. So ops proxy, or pluggable transports, is a Google Summer of Code project from like the summer before, where the goal is to make Tor traffic look like not Tor traffic, look like something completely different. Make it look like Skype, for example, which is now a different kind of pluggable transport that you can use, or Stegator is where it kind of tries to do streams and sizes a bit differently. So it's just a way of obfuscating Tor traffic so it doesn't look like Firefox and SSL. And so this was a Google Summer Code project. We thought we had more time. We thought that we could roll it out now. The plan was to roll it out in September 2012. We thought we had time to write some tests, get some like beta testers in, do it properly. But then Iran blocked Tor, like they blocked all SSL, and we figured, well, so far we've managed to get users online pretty quickly, so why not just roll this out now? So we did. It included building new bundles. It included getting a lot of volunteers to operate their servers, but they did. And users were back online within a couple of days. So this is the bundle where Tor does not look like Tor when it starts up and connects. The initial handshake does not look like Tor, and it's able to circumvent firewalls in China, in Iran, in Kazakhstan, in Ethiopia. It just works everywhere at this point. Uniprobe, that I quickly mentioned during the slide about the mobile censorship in UK and in the US. It's a framework with a lot of modules for testing whether or not the connection you're on is being censored in some way. So it will be able to kind of run different tests, see if you're behind a captive portal, see if they're blocking Tor, see if they're spoofing packets somehow, and things like that. And so when I'm working towards a plugin that will make it easier to, hopefully will identify exactly how they're blocking Tor, exactly what the fingerprint is. But the issue, like the challenge with that, is that it kind of requires a user inside the country. So in Ethiopia, to actually run this and test it against one of our servers, and sometimes you can't even find people in the country to help you out. And if you're lucky to find one, they're not always that technical. But it's going to be interesting to see how well it works when it's done. Hopefully later this year. And that was it. Any questions at this point? Sure, front row.
No to the front row. I was wondering if you have any insight or stats onto malicious exit modes. So I'm pondering, for all the fixes you've done there, if I was China or Iran, I think you've got around between 700 and 1,000 exit nodes. So if I'm China and I can set up a few thousand exit nodes on my control.
Yep.
And then do other kinds of traffic. So as opposed to, my circumventing of stuff a different way. So doing inspection of web traffic and figuring out, okay, this person, I don't know his IP, but I know he's logging into Facebook as Joe Soap from China, so now I'm going to give them some special attention.
So the question was, what do we do about malicious exit nodes? So an exit node or an exit relay is that last hop that is able to see where the packet is going. So if you're visiting Google, if you're logging onto Facebook, if you're reading your mail, anything like that. And so, yeah, there are people that will set these up and they will try to do, SSL strip is, huh? Yeah, exactly. I thought about that. And and just try to do something with your traffic. Some people just log it, which is like interception, like we talked about yesterday. Not really allowed depending on the country. Please don't do it kind of thing. But what we do have is we have like an exit scanner. Snakes on a Tour was a Google summer code project that will try, so you will run an exit relay yourself and then try to identify malicious exit servers. And when identified, we just take it out of that main list that clients will download so that they can't be used.
But so say if I was China and I set up 10 exit nodes in China,
Yep.
and I wasn't doing SSL strip, say, so Facebook, so Facebook, say, by default doesn't encrypt traffic, and now I'll just be sniffing your Facebook cookies, no one would be none the wiser, and then I would go and pay a special visit to John Soap from China, who is saying bad things about the government.
Yeah. So
I guess that's not really something you can.
No. So I think when it comes to kind of using, I think the same thing applies to using Tor as using public Wi-Fi's. If you're at Starbucks and Facebook has sadly not enabled SSL by default. Last time I heard they were at 30% and they're working on it. It's currently opt-in and you have to turn it on in your settings. But it's just all about kind of user education and telling people exactly what makes Tor different from a VPN, why it's so important that you use SSL, why you don't log on to Facebook if it doesn't have the S in the URL, and things like that. But apart from like, we can't really control who sets up an exit relay. We don't, like, as long as they're not clearly doing anything malicious, then we have no way of really controlling that. So it's just, that is one of the things that we do spend a lot of time on, is user education, telling people exactly what this means, exactly why, like in what case they would be or would not be anonymous when using Tor. Yeah, so it's just, it's a challenge, but yeah.
When you're looking at the graphs following a countrywide block, do you have any details as to why it doesn't go completely to zero? Do you think that's the in-country authorities allowing themselves to continue to use Tor? Because I noticed with some of them it dropped down to 200 users and then remained stable. Is that them monitoring how well their blocking's working? It
could be. It could be that they have, for example, in some cases, in the UAE, universities will have a different set of rules so that they can connect to Tor. Well, if they go home to like their normal whatever ISP they have like in their home, then they're not able to connect to Tor. So I think it's like probably like that, the authorities, universities, things like that, or different ISPs that just haven't, for some reason, like that the block is happening on like an ISP level and not a higher up kind of level. Yeah, so, but I think last time I heard there's a lot of universities that just have like a different firewall rule and they're able to do different things.
Is your OmniProbe software intended for public release?
Sorry?
Is the probe software that is the stuff that's intended to identify how they're blocking it, are you planning to release that?
It is open source. Everything we do is open source, free. It's on getweb.torproject.org. So yeah. But so doing how the blocking is done, it's a lot about, it's not always that straightforward. If you happen to know a user inside the country, you can ask for some help and have them test some stuff. But in other cases, it's more, you can try and create packets that look like Tor and just send them to a live host in that country and see what the firewall does with it. So you can get around it, but yeah.
Have you, if I was a country trying to block Tor, I think the first naive approach would be DOS or DDoS against your infrastructure, because if your users can't download your bundles anymore,
they can get it via email.
They can get it by email, but I guess my question to you is, do you experience any DDoS or something that you presume come from countries? as opposed to...
We see some interesting things every now and then. Not so much DDoS. There was one of the main servers where clients will download the list of relays from, got hacked a year ago, but I think that was just like someone just happened to manage to hack into the server. They had no idea it was related to Tor, so they didn't really do anything. But apart from that, it's kind of so Tor is set up in such a way that you can't really, if you DDoS like one server, then Tor is still up and running. Volunteers are running the main network. We just developed the software. So there's no way of like, if you take me out, then you win. But yeah.
What happens if you take out the directory authorities for long enough?
If you take it out for long enough, then eventually, so we have 8 at the moment. There are some in the US, some in Europe, run by like 8 different people, some associated with the Tor project and some not. If you take out all 8 for long enough, then they will not be able to generate that list of relays, and clients will not be able to get that info, and so they can't connect. I think it's coming with the microphone now.
How do you get your nodes to upgrade so quickly? When you say in 24 hours, how do volunteers have manually to download the new version? And
so in some cases, it really depends on what the fix is. For a lot of the issues, it was like a client-side fix. So we just updated the Tor browser bundle, and we told people who emailed that, oh, you need to download this new version. In some cases, when we rely on volunteers to upgrade their servers, we email, we tweet, we contact them directly, because in some cases they will include their contact info. And people just really seem to really want to help out. We had a couple of hundreds of people set up new servers for people in Iran within like 24 hours in February. So we just have like a really, really great group of volunteers that help out.
Have you had any cases where people running exit nodes have come into trouble with authorities for the websites they're connecting to, and how have they been dealt with, and how have you helped them out?
Are you thinking about bad people doing bad things? Or
no, just say someone was using the Tor network to browse to, say, inappropriate sites, and the traffic seen coming from someone's IP address to those sites, and how authorities have dealt with them.
So this has happened, I think Germany is a good example. One of the Tor project developers, before he became a developer, he was a student in Germany. He was running an exit relay in his room, and one day the police was on the door because someone had used his exit relay to look at child porn, I think. And that running an exit relay means that you allow anyone to just use your server to visit whatever website they want. Which means that you also, according to some people, you are kind of ultimately responsible for that. So in the cases that does happen, some people do get their servers taken for a while, but then we do recommend that if you're running a Tor exit relay, don't run anything else, so that if it is taken by, say, the FBI, and you're probably not going to get it back for a while, then at least there's nothing else on there, right? And Tor doesn't log anything, so the only thing that they will see is that you're running a Tor exit relay. We also do work with law enforcement. We kind of help them understand what Tor is and what it's not and what it's capable of doing. And we kind of help them understand that we don't have any logs, that we don't store anything, that Tor by default does not store anything. When it comes to helping the users, in the US, we're good friends with the EFF, the Open Rights Group and Privacy International here. So we kind of try to get in touch with kind of local groups like that can help the users out, or at least help them find a lawyer who knows something about Tor or is actually able to understand technical words. So we try to help them, but at the end of the day, if you run a Tor exit relay, then hopefully you have read the website, you have read the instructions, and you know what you're in for. So, yeah.
Hi. When you distribute the client via email, do you have any problems with distributing the a hash for the client software as well?
So in the, we sent out it's like a zip file or like a 7-zip file that includes the signature. So if you do have GPG installed, then you can verify that that bundle is exactly what we intended for you to get. But the challenge with that is that verifying signatures for package on Linux is really easy. OS X, it's like fairly okay. Windows, if you're non-technical, it's like a pain in the ass. And that's something that we're kind of working on. I wish it was easier to do. There's a lot of people that probably just download the bundle, and because they have absolutely no idea what this verification thing is, they just don't. But yeah, you have the ability to verify the signature if you want to do that.
Do you have any experience of people running Tor exit nodes on cheap hardware?
On
Cheap hardware.
cheap hardware,
My thought being that if you were to run it on, let's say, a Raspberry Pi, and somebody did say, want to confiscate it, you could give them the SD card, image another SD card for £2 and job done.
yeah, running exit relay on a Raspberry Pi, I don't think anyone has tested. So if anyone does want to test, let me know. Bridge has been tested, and a normal relay that just passes traffic on to somewhere else within Tor has been tested, and it works just fine. So I'm pretty sure it would be able to handle exit relay as well. There are people running Tor on routers, like Buffalo routers. I had an old Linksys that was able to run as a client, but the second I set it up as a bridge, it crashed. But that is something that we're also working on. We had the Tor router project where we really wanted to put Tor on like a cheap device, configure it as a bridge by default, so that if you want to help out, you know what Tor is, but you're not technical enough to set it up, you can just buy this thing and plug it in and it works. So we're kind of experimenting with that, and it's something that we're going to roll out next year. I have been talking to the Raspberry Pi guys, but they're also really busy. So maybe we can get something going there. Huh? Sure, that would be great. I have one. I've been meaning to set it up. I'm just too busy.
Just following on from that, have you looked at integrating into like DDWRT, the sort of open source routing?
So we have OpenWRT was what we looked at when we had the Tor router project. The problem there was the whole package management system. Whenever we upgraded Tor, it was, for some reason, it took forever for the new release to make it into OpenWRT, and it seemed like if you were running an old version, you had to like reflash your router to get the latest version, and it just wasn't as user-friendly as we thought it would be. Anyone else? Yep. It's coming.
So the OpenVPN runs a service in China, and periodically they find that China has shut down multiple endpoints. And watching this pattern over a period of time suggests perhaps they're doing heuristics on traffic analysis to identify endpoints that maybe have less plain text and more compression, JPEG, or likely VPN traffic. I don't know, but I wondered if in your reflection on the China problem, you had an idea about the strategy that they're taking in terms of reducing unwanted connections.
Yeah. Unwanted connections from within China?
Outbound connections, yeah. What China's doing to, the strategy that China is taking to limit unwanted outbound connections. And I mean, we are contemplating whether they're trying to attack protocols per se, or endpoints per se, or DNS poisoning per se.
I think it's just kind of protocol, mostly. Like, they care more about what people are doing, like what they're searching for, what they're Googling.
All of that ends, though, if it's encrypted traffic, right?
Well, they do have deep packet inspection.
Yeah, I don't, VPN packets I don't think are
It's
being
kinda-
inspected, right?
It's China. I mean, I don't know. The paper that Philip wrote is really interesting. It also lists a couple of IP addresses, one which is probably one of the main IP addresses for like the firewall that actually does the follow-up scanning. So if you are running a VPN server, you can grab your logs for that and see if you have it. But I don't know. I mean, they keep coming up with something new every day. It's kind of hard to say exactly what they're trying to do. My guess is like they're just trying to covering all bases. So whatever they can do, they will. But yeah. Anyone else?